Welcome to part 3, and today we're going to look at driving an active subwoofer. Greetings, the Astro 30 here, losing my voice because of screaming at stupid dickhead drivers in Tasmania that don't think giveaway rules apply to them. Anyhow, I will soldier on somehow. Today we're looking at a subwoofer controller, an ELF, which is extended low frequency, which is actually a trademark, or an electronically assisted subwoofer, or EAS. Basically a preamplifier for an active sub that was just seen in the first shot there. Now, basically all its job is to do is to amplify the low end frequencies and boost them more than any other frequency, because driving a subwoofer doesn't seem like a hard task like driving any normal speaker, but it is. Because you're not actually driving the speaker to the resonance of the cabinet, you're actually driving it below the resonance of the cabinet. And if you drive it normally without, boosting the low end frequencies, you wouldn't get much response out of the speaker. And I had to stop there because I needed to take a shit. So basically, we're looking at a circuit that boosts the low or extends the low end frequencies of the spectrum, and only those frequencies, to successfully drive the subwoofer. So I'll leave it up to your discretion to look at Rod Elliott's website link that I put in the description below to see an in-depth discussion about how this circuit really works. So I'm not going to waste any time on going into it anymore. What I'll do is I'll breadboard this out, and we'll stick it on a scope first and see what it does, and then we'll actually hook it up to the powered sub here on the desk and see how well the circuit works. So let's get cracking. Okay, a short time later, I've got it all breadboarded out. As messy as it is, it should be functional. Got the power supply set to 15.1 volt plus minus. The DDS is currently set at 60 Hz 1 volt. That may change. Got the mini DSO hooked up because it's convenient. So with a bit of luck, if I turn this switch on, we should see some form of output. I've got the output level control full up, and I've got the other one about halfway. I can sort of see an output, currently pushing an output of 59 Hz at roughly 200 millivolt. So if I increase the gain control, we can see a significant increase there. We're currently pushing about close to 6 volt peak to peak, and that's with 1 volt in, and that's with the gain control full up. Of course, that gain control would not live at maximum, because the more input power you give it from the preamp, the more it's just going to distort the circuit. So this pot really is there to add control over the distortion of the controller. So you would set it so it wasn't actually distorting. Okay, that's at 60 Hz. So let's see what we're getting at a frequency of 50 Hz, significantly bigger. So we're actually pushing, well, if I up the gain all the way, we're pushing about 8 volt peak to peak. So I'll change that so we can see it, and we're not clipping, so that's fine. So I'll change my amplitude input to 2 volt peak to peak, and again we've got a significant increase. and we're now pushing 16 volt peak to peak out, and that's with the gain control full. So at 50 Hertz it is quite easy to push quite a hell of a lot of output voltage. So if I change that frequency now to an even lower base frequency of say 20 Hertz, now it's starting to look a little shit. So if I back the gain control off, we can see now that it looks fine. That's the whole entire point of the gain control, because full up we're clipping, back it off, we're no longer clipping, and we're actually pushing 22 volt roughly peak to peak out. So you can see the lower the frequency you go, the more output it will produce. The higher the frequency you go, the less it will produce. So if we went to 100 Hertz, say, it drops right off to 2.4 volt. Now that's kind of the desired operation, because we're really only interested in the low end frequencies, like below 50 Hertz really. I now know that circuit works, so what I have to do is hook it up to a sub in a minute and a music source and see what it sounds like, and play with the controls, etc. But first what we'll do is I'll do a sweep test on the circuit and see roughly what frequency it starts to roll off at. Okay, so currently we're doing a sweep, and we're going from a 20 Hertz down to 500 Hertz, and we can see it's rolling off quite significantly. I would say around about the 60 Hertz range is where it really rolls off. Yeah, and now I can't even register it. So it is doing what it's supposed to do, which is filter out the mids and the highs, and you'd be looking at roughly a center frequency of 60 Hertz. So now to hook it up to a subwoofer and do a sound test. Okay, I got the active sub now hooked up to the circuit, and if I touch one of these input caps, there we go. So we know that that's working, so I'll back the level right off. A bit more respectable. Now I will hook up the input source to the circuit and we'll do a sound test. Okay, so I've got everything hooked up, both channels, the output of the amplifier over there. I've turned the bass back to the center position on the amplifier because the track I'm going to play is pretty bassy and I don't need the bass coming from that speaker over there. I need it from the subwoofer on the floor down here. So here we go. I'm going to play with the controls at the same time. See how powerful that is? Okay, I'll kill the sub. It works perfectly well as it is with no modifications. So the next thing to do for this is to make the circuit board, because this is going into the amplifier obviously, and the headphone amplifier, which was discussed in the previous video, will also be on the same board, so we can ignore that. So I'm going to spend the rest of the afternoon routing a PCB for it. Now that I've tested it and made sure it actually does work with the component values I'm going to use. Now this 50k pot that's just out of shot here, That should have been a 20k linear, but I can't get 20k linear in that size, so it has to be used with 50k. According to Rod, you can use it a higher value up to even 100k with modifying a few of the values of resistors. So for instance, at one side of the pot there, he's got a 10k resistor going into the input of U1B of pin 6. You could probably decrease that to say 4k7 to use a 50 to 100k pot, and the same conversely for the 10k on pin 2 of U2A to a 4k7, just to give the gain control a little bit more headroom per se. But yeah, for what it is, I'm quite happy with the way the control is at the moment. So whilst it's working in that configuration, I'm just going to leave it alone. So anyway, I'm going to get busy routing a PCB. I do not know how long it's going to take me to do. I've already started it last night, but haven't finished it. So yeah, probably in the next 4 hours I should have something to do. Anyway, we'll check back when I've done that. Goodness. Okay, and about 2 hours later the board's all routed, and I've just developed it and just checked it for errors and stuff in development. Seems alright. So next task is to etch it. So yep, about another hour and a half I reckon I'll have it etched, drilled, cut to size and prepped ready for solder. What's the time now? That's a good question. The time is, according to my clock, 2 o'clock. So yeah, by 4 o'clock I should have this somewhere in the realms of ready to assemble. So there's the circuit board all etched, drilled, protected and cut to the correct size. All components fit through the holes. I've just noticed a little bit of a thing there. I don't know what that is. I don't think it's conductive, but anyway, it's ready to assemble. I'm going to start with link-wise. There's only 3 IC sockets, resistors, etc. The standard, the norm, and yeah, I'm going to do that in time lapse as usual. I think that was just crap. That's not actually copper or anything. It's just probably hairs off of me paper towel when I was wiping the resist off. So mount this in the tool, get going. Right, and that's the circuit assembled. It took me about probably an hour and a half. I did stop a couple of times in between. Just going to insert the 3 NE55332s. Otherwise it's not going to do much. Luckily, last but not least, here we go. All 3 ICs are in. Now, this capacitor is very close to these 2 connectors. As we can see, it's extremely close, but the connector plug does actually fit on there. That's what I was playing around with. And I reckon it will just clear this 4-way. This 4-way is the output to the 2 power amps. So there's 2 grounds in the middle, the left on this side and right on that side. It's left on this side, ground right on that side. That's the input. Now, I'm using the headphones socket's DP-DT switch inside to switch the input to the rest of this circuit plus to this output connector. When the headphones are unplugged, it allows the path to go through all this circuit here plus the output connector. When you plug the headphones in, this output is disconnected. So are the rest of the electronics over here, well, the sub-processor anyway, and the only thing that's switched in now is the headphone amplifier, which is over here. That's the theory anyway. So I suppose it's ready for some testing. I'm just going to mark my negative point so I don't blow the asshole off of it. And this is the sub-bass output. So I'll hook it up to a power supply in a minute. I'm going to have a bit of a break for a couple of minutes and then we'll test it out and see if well, we can make some noise. Probably should put it on the scope first just to verify that the subwoofer controller over here is working appropriately. So yeah, let's get on to that. But first I'm going to verify the operation of the switch of this headphone socket. Now that side is the right. We have continuity through to the output, which is good. And that also needs to go off to, well, if it's at the output, it's going through these capacitors, so it will be over here as well. Other channel. Brilliant. Now plug the headphones in. Well, the adapter in anyway. That's now dead. That one's now dead. But it should be present there, and if I can get in there, maybe not, so I'll do it the other way. Yep, so the operation of that is fine. That should now disappear from here, which it does, and should reappear where it's supposed to be. Okay, there we go, and the reason I'm using that is so it will mute the power amplifiers and it will mute the subwoofer without having to, you know, modify the other circuitry to drop the relays out. That just means, however, that the 2 power amplifiers will still be powering the speakers. Well, won't be producing any sound, but there'll be, you know, static and hiss there. But it won't be driving any signal through. So that's probably the easiest way to mute it, is to use the headphone socket switch. Anyway, continuing on with testing. Okay, I got everything set up again. I've got the DDS at 100 Hz 2 volt. Got the oscilloscope hooked to the subwoofer output. Got these controls relatively high. So as soon as I turn the power supply on, we should see an output. Which we do. We're pushing currently 4.0 0.09, but if I rotate that all the way, 4.5 volt, but that's at 100 hertz, so I'll put it back to what it should really be, which is, I reckon it was about 50 hertz was the maximum, so hertz. There we go. Ooh, significant increase. I'll have to increase the volts per division. There we go, we're pushing out 15.8 volt. Nice. That little circuit is working. The gain control does something, so does the level control. So I know that that's functioning. Now, if I, for instance, plug in the headphone adapter, the signal should go away, which it does. So I'll just unplug that again. Okay. I'm only on the left-hand input channel. I mean, it doesn't really matter. But I'm going to hook over to the right, make sure that that's going through to the circuit, which it is. So what I'm going to do now is I'm going to test that the headphone amplifier is working. I can hear 60 hertz. So I'm going to change that to, because that just sounds like mains hum. I'm going to change it to 500 hertz. That's better. That is indeed coming out the left-hand channel, even though this is marked as right. That one sounds louder for some reason, I don't know why. Yeah, well that's interesting. The right-hand channel is louder. Alright, well I've fixed the imbalance issue in the headphone amplifier. What the problem was, I had this 2K2 resistor over here and this 22K resistor over here. Those two resistors were swapped around, so that's why there was extra gain on the right hand channel. Anyway, that's now fixed, and the headphone amplifier actually does sound pretty good, so I know that's working now. Excuse me, now I can move on to testing the actual sub. Okay, the subwoofer's hooked up, so I'm just going to select a decent track and let's see what happens. Cheers. Sub goes away, sub comes back. Okay, that's enough of that. That song does get annoying after a while. Anyway, for a project by Rod Elliott of Elliott Sound Products and, well, a silicon chip headphone amplifier, combined together, works beautifully. So this will be used in my amplifier design. That was going to be my hardest task, was laying all that crap out, but I've done it. Yeah. So anyway, I'm going to leave with another song in a minute, but if you enjoyed this video, please remember to rate, comment and subscribe below. And if you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, happy subwoofer. Not sure what that actually means, but yeah. And just before I go, there's the complete schematic there, which I'll upload as a link in the description, so you can look at the full schematic, including the tone amp, volume board, and sub bass controller. Anyway, this is the Astro 30 saying, see ya, have a great day.